Okay, we're going to look at another example of how to solve using the quadratic formula. Um, Today we're all about finding our rational solutions. The first example I showed you where we came out to, whole numbers, rational numbers, meaning, we can write them as a fraction. It doesn't have a repeating decimal. We're physically able to write those numbers down. And those numbers come from that stuff that we saw underneath the square root. So the example that we saw first, okay, this guy here, we had a 169 underneath the square root, which when we put that in our calculator, that turned into be a whole number, right? The square root of 169 turned into a perfect 13, okay? So the examples that are going to give us a rational number are what is known as our perfect squares. Now, you have heard of perfect squares before, okay? If you forgot it, it's not a big deal, but here they are, okay? So on the right is what a perfect square would be. As you can see, I have numbers listed from 0 to 15. Okay. And on the left are the radicals or the square roots that get us there. Okay. So what would be a perfect square? What times itself gets us to a number, right? So if you can see all the numbers that we square on the right is going to get us the number on the inside, right? 3 times 3 is 9. 6 times 6 is 36. So anytime we have any one of these numbers on the left, right? Anytime we have any of these numbers that are underneath these square roots, you are going to get a rational number, okay? So if you want to jot these down, kind of real quick, or, as you're just kind of going with this quadratic formula, how we did in our calculator, if it comes out to be a perfect number, let's see if I have my old example. Yeah. So like we did here, okay, so the square root of 169 is a 13, right? So that's way down here on the list, right? Square root of 169 is a perfect square. We're able to perfectly say that's the number 13. The square root of 12, however, look how big that decimal got us. We are not able to write that number down. This would just simply be an approximation. Notice how on the perfect square lesson I made for you, right, there is no 12, okay? The decimal is 3.46, so in between 3 and 4, right? Notice that's where the 12 would have been. So we don't have a perfect square value for that, so that lesson's going to be tomorrow. So all these rational values, all of these perfect squares are what we're going to deal with. Now, I only give you the 15. Understand that there are perfect squares bigger than 15. The square root of 400, is 20. Right, that would be a perfect square there, okay? But I'm not going to give you anything bigger than this list here. We're going to stay within 15 here. All right, so here we go. Here's our example. So again, we're dealing with a quadratic. We've got our x squared term. First thing right off the bat, before I have to use quadratic formula, I would write down what a, b, and c are, okay? Just until you get used to it, write down what those values are and what they represent. Remember, a is with the x squared, b is with the x, c is our constant. All right, here we go. So let's go ahead and substitute this into our formula here. X is equal to the opposite of b. B is a -2. Remember, just actually kind of similar to our last example, you have the double sign. That's fine. If you're using our parentheses, it doesn't affect us at all. So now we have the positive and the negative case. We talked about how that affects our problem there. B squared, b again is a -2. Again, if we don't use our parentheses, you're going to get yourself in trouble. You need to make sure you are using your parentheses. That's something that, very early on I was stressing to you. Anytime we substitute a value in for a variable, right? Anytime we are substituting, you need to use your parentheses. Okay, this is no different. Minus 4 times the value of a. A we determined is 8 times c, which is -3. And again, that's fine. We're just going to extend that square root. Understand that everything there is underneath the square root. And all of this is now being divided by 2 times the value of a. All right, again, this is a huge step with this. Being able to recognize what the A, B, and C values are and be able to accurately put them into the formula. Okay, well, going down our steps, the next step tells us to simplify the stuff underneath the square root. Cool. So the stuff that we have underneath the square root, Again, calculator definitely helps. You can do it by hand, but calculator is definitely going to be more efficient here. So again, I'm not going to use the square root. I just want the stuff underneath of it. So parentheses, -2, parentheses squared, -4, parentheses 8, parentheses -3. Okay, again, this is word for word. Exactly what you see underneath the square root. Boom, we're going to hit enter. And it tells us 100, okay? So now that it told us 100, I'm going to go ahead and clean up all of that junk underneath the square root to combine it a little bit. So x is equal to, once you get the hang of this, you can already see that this is going to be a positive. You want to go ahead and write the +2 down. It doesn't matter, but this is kind of more of a methodical approach. Kind of when I see this saying, this is the first thing I want to break down. Okay, so again, you can jump that step if you want. Same thing here. 2 times 8 is 16. If you want to go ahead and write that down, by all means, it doesn't hurt. All right, so the stuff underneath the square root went to 100. Well, again, these are rational examples. And if you see from our list over here, the square root of 100 is a perfect square. It does have a number that when multiplied by itself, it gives us our value, right? The square root of 100 is 10. Okay. Actually, the next step that I kind of had you write down was to kind of go ahead and clean up those negatives and this denominator here. Okay, so a -2 again turns into a +2. We've got this plus and minus case. We're just going to leave the square root alone for right now, and let's clean up the bottom. So these two steps, again, very similar. You can kind of go ahead and skip that if you can kind of see what's going on here, the 2 times 8. You don't have to keep writing it 2 times 8 if you don't want to. Okay, so the next step, step 4, says take the square root. Okay, so now I'm going to get rid of the square root value, okay, and turn it into our perfect square value, right? So x is equal to 2 plus or minus. Again, the square root of 100, right? We have that perfect square. We know it is a perfect number 10, right? So the square root of 100 is 10. Again, the misconception, notice how the square root went away, okay? The square root of 100 is not the square root of 10, okay? The square root of 100 is perfectly the number 10, okay? So make sure we are getting rid of that square root bar, okay? So now this is as simplified as we can get until we start hitting these plus and minus signs, okay? So now that we've got this plus and negative, let's go ahead and break out these two cases, okay? So I've got one case being the positive case, x equals 2 plus 10 over 16. And I have the negative case, right? This guy down here. All right, I have, give me some room, x equals 2 minus 10 over 16. Okay, so we talked about last example how those two signs there that's in our formula, that plus and minus, actually do turn into two separate answers there, okay? So now that we've got them broken into our two cases, let's go ahead and simplify them. So I'm going to go ahead and take care of the numerator. 2 plus 10 is 12. Over here, 2 minus 10 is a -8. So if you notice, these are going to turn into a fraction, right? 12 can't be divided by 16 perfectly, and -8 can't be divided by -8 can't be divided by 16 perfectly either. It's fine. Fractions are perfectly, these are rational numbers. Rational numbers are represented with a fraction. So again, if you have a calculator, by all means, good. If not, you've got to be able to simplify that, right? 12 and 16 are both even, so you can cut them in half, say 6/8. Keep cutting them in half, right? You've got to be able to simplify a fraction. Get into its simplest form. If not, your calculator, Calculate84 app, will do the trick for you. So 12 divided by 16, okay, it's going to give you this decimal. We don't want the decimal. Just get in the habit of using the fraction. Remember, math, down the left-hand side, math, enter. That's going to turn you into a fraction. So 12/16 simplifies to be 3/4. So x equals 3/4. Right, that calculator will give you its simplest form. And the last guy over here, same thing. Let's go ahead and put that in our calculator. You should be able to see that that's going to be a 1/2. But just double checking your calculator. Again, negative 0.5. Math, enter, turn that number into a fraction. And yeah, it's going to tell us a negative 1/2. 8/16 is a negative 1/2. So x is also equal to a negative 1/2. Okay, so those are your two solutions for our quadratic formula. And again, I know it's a lot of steps, but you know, the more practice and repetition that you get with this, the kind of more methodical it becomes. It's just a lot of evaluating, just a lot of simplifying. Okay, the better you kind of are with your simplifying, you know, if you have a calculator, it definitely helps out some. But there's not too much thinking involved here. Just being able to, you know, break down that giant equation there. Okay, so I'm going to show you one more example. I'm going to break it down just like you saw here. You don't have to watch every example. If you kind of got the hang of it, and you want to get into some examples or the assignment on yourself there. But understand that I am going to show you one more example. Okay.